Alright, what's going on? Adam Coobs here. So I'm going over the opioid anesthetic, whatever, you know what I'm talking about. So yeah, this is gonna be the first video. So opium, opiates, and opioids, right? So opium is the milky fluid obtained from the poppy seed, which is the actual opium, and the opiates are the components of that sap. So example is morphine and codeine. And has used since ancient time for anesthetics since 1800s. Morphine was isolated from opium, and heroin was synthesized in the late 18 as a safe alternative for morphine. In 1900s, you saw the development of dozens of synthetic opioids, and to understand that opium's original, the difference between opiates and opioids is that opiates include morphine and codeine, and they are actually made from the components of the sap, versus opioids, which are synthetic. And so you have, in the 1970s, these opioid receptors were discovered, and they're natural ligands that are endogenous to those opioids, like endorphins, and the three main types that are reactive, which is mu, kappa, and delta. Now, mu receptors are the only ones that are thought to have significant analgesic effects. So mu is the most prominent one that has the biggest effects, and those are found in all areas of the brain. All areas of the brain, spinal cord, involving anesthesia. So opioid pharmacodynamics: pain begins in the nociceptors, and substance P and glutamate are released in response to the pain, and that's when opioid analgesics come into play. They can activate endogenous opiates, i.e. endorphins. So that's the endorphins, whatever, or GABA neurons, to inhibit the release of substance P, and glutamate affects the brain's areas like the paracortical gray, which leads to activation of endogenous opiate systems and increase the dopamine output of NCA. And we're talking about NCA as in sodium channels. And the general effects of opioids is analgesia, euphoria, sedation, and analoxis, which is anxiety, respiratory depression, cough suppression, pupillary constriction, nausea, vomiting, gastrointestinal symptoms, and histamine release. General effects of opioid receptor activity. So tolerance and withdrawal, chronic use can cause dysregulation of endogenous opioid systems. So a number of processes are hypothesized to be involved with that: decoupling from G protein, downregulation, a whole bunch of different things. It also leads to a number of withdrawal symptoms such as tremors, cramps, pain, flu-like symptoms, diarrhea, dysphoria, which is the inverse of euphoria. And euphoria is basically having like a really happy, excited, state. Malaise, anxiety, and insomnia. Withdrawals is not really dangerous, but it can last for several days. And with overdose, death often attributed because of respiratory depression is associated with pulmonary edema, which is basically a filling of liquid in the lungs. And the exact mechanism for overdose is not really always 100% clear. Definitely, polydrug increases with risk, meaning the multiple use of multiple drugs while taking opium type things. So morphine is the most potent opiate, and normally is given intravenous, mainly medically, but also inhaled when used recreationally. Reaches all tissues through the body, meaning that it crosses the blood-brain barrier, also the placenta. Not teratogenic, but meaning that it causes birth defects or abnormalities, but it is dependence producing, meaning that it can mess with fetal development. Also metabolized, morphine is metabolized by the liver enzymes into morphine 3-glucuronidase. Morphine 6-glucuronidase, and which is also MG6. Now, MG6 is also a potent analgesic. All right, I say this word wrong all the time, but anyway, it's important and it works. The metabolite MG6 works on the body still and is very potent. So the half life for morphine is 3 to 5 hours. So there's codeine as well as an opiate, and is about 10% the strength of morphine, and is metabolized by CYP2D6, cortisone P2D6. Because of its milder effects, is used in formulations to treat cough. There's heroin, which is actually 2 to 3 times more potent than morphine because it's more lipid soluble than morphine, and it also crosses the blood-brain barrier quickly, more faster than morphine does. Heroin is actually a prodrug, which means that it has to be broken down by the body before it becomes in its active form, and is actually rapidly metabolized into the brain. So the other opioids, as well as hydrocodone, Lortab, Vicodin, that's what it's also called, made from codeine or thebaine, similar strength as morphine, so it's on the same level, often combined with non-opioid pain relievers. So you also have Oxycodone, Oxycotton. So that's would be like Oxycodone and Percocets. Percocet is oxycodone mixed with acetaminophen, and oxycotoxin. Oxycotton is nearly pure oxycodone. So it works in a time release form, but when abused, it is all released at once, and is developed initially for cancer related pain and aggressively actually marketed for non-cancer related pain. So treatment for that dependency would be methadone, opioid agonist, slower acting than heroin, but more slowly metabolized. There's no rush with it, not completely safe and can cause dependence. Buprenorphine, opioid partial antagonist, also with Subutex mixed with naloxone and Suboxone. Naloxone is actually opioid antagonist. So you have Subutex, that's opioid partial agonist with buprenorphine, and also partially antagonist. But anyway, with naloxone, you have rapidly precipitates withdrawal. It basically reverses overdoses, right? That's what you're saying. Some notes for no notes right now. That is the end of the video. Catch you in the next one.